there was a question on Stack Overflow that reflects what I often hear in person. It says, I'm really struggling to understand unit testing. I do understand the importance of TDD, but all the examples of unit testing I read about seem to be extremely simple and trivial. And he goes on to say, I think my main issue is I can't find any practical examples. Here's a method that seems to be a good candidate for testing. What would it look like to have a useful unit test? Well, let's take a look, and I'll tell you. So here's the method in question. It's called setReminderID. It takes an argument, but it doesn't actually use it. So I'm going to consider that cruft, and we'll just ignore it. It returns an NS number. And what does it do? Well, the first thing it does is it goes into NS user defaults, and it gets an object for the key current reminder ID, and it saves that. It presumes that that's an NS number, and it saves it away. And then it says, if there is such a value in NS user defaults, then get its integer value and add 1 and store it back. So increment it, basically. Otherwise, if there is no such value stored in the user defaults, then set it to an initial value of 0. Once it has that, then it goes back to user defaults, and using the same key, it sets that value back in for that key of current reminder ID, and then it returns the value. So basically, it's a persistent counter. How do you go about unit testing this? And the trick is, the stumbling block is this. This method is not self-contained within itself or even within its own class. It has a dependency on an external object, and in this case, it's NS user defaults. We don't want to use the real NS user defaults. Well, you could if you really wanted to, but it'd be kind of a pain because your test would have to sort of save away what was there before, if there was anything, and then after the test restore it so that you wouldn't mess up your manual testing through the simulator. Instead, what you want to do is inject a fake user defaults. That way you can control what's inside of it, what it returns for this top portion, and you can see what's set on it at the bottom to make sure that the right thing was done to it. So how do we do that? We do that with a thing called dependency injection, and there are a couple ways to do that. One way is to expose it as a property. Then after creating the object, set the fake user defaults into it. This is called setter injection. One thing I like to do with setter injection is have the initializer set up a reasonable default value for this property, in this case the real NS user defaults singleton. Another way is to provide it as an extra argument to the initializer. This is called constructor injection. A big advantage to constructor injection is that it makes the dependencies explicit when the object is created. Now, you may worry that you'll end up with a monster list of arguments, but what this is telling you, what this pane is telling you, is that you may have too many dependencies, which probably means you have a second class inside that's trying to get out. So it's a good thing. So which do we use? The rule of thumb is prefer constructor injection, but you can always fall back on setter injection if you really need it. So let's get started with a new Xcode project. CocoaTouch static library is fine, although there's nothing iOS specific we're doing today, so it could just as well be for the Mac as well. But moving along, I'll call it TDD example, and I'm including unit tests, and we use Arc. Create. Now, Apple sets us up with a test template that I really don't like because it has a header and an implementation in separate files, .h and .m. That's unnecessary for almost all test cases. So let's toss them in the trash. And since this is a TDD example, I'm going to get rid of the initial template class as well. We'll just have a clean start. Close these up since I'm not really going to use groups. Now, since I don't like Apple's template for test case classes, what do? The answer is go to qualitycoding.org and click on Resources, and then scroll until you find the unit test template. That's mine. Download it. Now, go there in the terminal and we'll do a make install. It shows you what's installed where. And with that, let's quit Xcode so it has a chance to find that new template. And there it is. And one here for iOS and another one for OS X, OS X. I am going to add a couple of frameworks to help me out. If you go back to Quality Coding Resources page, you'll see I have OC Hamcrest. I wrote OC Hamcrest, wanting to have better test assertions that were more powerful and less fragile than what OC Unit provides. So let's download that. And while we're here, for mock objects, now for mock objects, I do recommend starting off creating them by hand. You'll get a better sense for what they're for and how they work. But let's skip ahead and go ahead and download OC Mockito, which I also wrote for mock objects. And let's get both of those in here. If we open up Hamcrest, you'll see that there are two versions of the framework. One is for OS X development, the other is for iOS development. We want the iOS one. I'm just going to drag that in. Make sure it goes into the test target, not the main target. You can use Hamcrest for main target stuff, but that's not what we're going to talk about today. And that's it. It's done. It's ready. On the Mac, you do have to do a little more setup of a copy files build phase, and that's explained in the documentation. So let's grab Mockito. It's the same story here. Grab the iOS framework and pull it in to the test target. And with that, let's go to Simulator. Let's expand this to full screen. We are ready to roll. It's time to learn the 3 steps of the TDD waltz. It goes like this. Step 1, write a single failing test. Not a whole bunch of them, just one. Step 2, write the simplest code to pass the test, and all tests should continue to pass. Step 3, refactor to make the code clean. Both production code and test code should be refactored, and repeat, and you'll be gliding across the floor. So back to Xcode. Let's find our new test template. There it is. It's the big green check mark. We'll pull that over into our project. I don't know what the class is. I don't have enough context to give it a name. So I'm going to cop out and call it example. And so the test class is example test. Make sure it goes into the test target. And yes, I'm going to uncomment these two lines to give me Hamcrest and these two lines to give me Mockito. Get rid of this example. And we are ready to roll. Type test. Now I have code snippets to help me go faster. You can get these if you go to my blog, qualitycoding.org, and subscribe. You'll get them as a subscriber. Or, of course, you can always make your own. Test. Now this shows me the basic setup of pretty much every unit test. It's got three parts. Given something something, when I do something, then what do I expect to happen? Or in other words, this is the setup of the precondition. This is the execution of the actual part that's being tested, and this is the verification. So let's start with a simple test. What I want is to see that the method in question returns 0 if NSUserDefaults doesn't have that key that we want. Remember, if there is no key object for that key, it defaults to 0. Using Hamcrest, I say assert that the object I'm going to call SUT for system under test. I like doing that across my tests because that lets me quickly copy test code. I'm going to call the method next reminder ID without any extra argument. And I want it to be equal to 0. Like that. Now, we want the mock object to say, the mock user defaults to say, no, I don't have an object for that key. So let's first create mock user defaults, and with Mockito it's easy. You say mock a class. What class? NSUserDefaults class. And using constructor injection, say alloc init with user defaults. You'll note that none of this has been implemented yet. And I started from the bottom up because unless you can express your verification, you haven't yet figured out how to test what you want to test. So it's good to start from the bottom and then go back up and say, how do I get there? And we pass in the mock. And we need to set up the mock to say, given a certain method call that we expect, say mock user defaults object for key of current reminder ID. Given that, it will what? Return nil. Like that. And there's really no separate execution phase because it's all wrapped up in here. Now you should be able to read this test code even if you've never seen Hamcrest or Mockito and have a pretty decent idea of how it works. Try to keep your test code dead simple. Let's give it a good name. Next reminder ID with no current reminder ID in user defaults should return 0. It's very long and wordy, And you notice I'm testing very little. I'm just testing that it returns 0, nothing else. Now, this still doesn't compile, of course. It still doesn't compile because we need to create the actual class. Make sure that goes into the main target. And let's get rid of this file header comment stuff. It's just noise. Okay, so now it's not complaining about example.h. It is complaining about a couple other things. Now, let me show you how I set up my screen for the best workflow for TDD. Let's hide the utilities panel. I have the test selected. I'm going to option click on the header file. Brings it up there. And then still holding option, now holding shift. So shift option click on the implementation. That brings this up, and I say double click on the plus here to bring it into the bottom right. So what this gives me is everything I need. I've got my test code over here. I've got the class that I'm building over on the right side with the header up here and the implementation down here. Now let's give it these methods that it's complaining about. That semicolon there, and we don't really have any initialization yet. I'm just going to kind of ignore that argument. That's a perfectly valid initializer there. Pretty sparse, but it'll do. Now, we need to implement next reminder ID, and it's going to return an NS number. Copy and paste like this. What do I want it to return? It has to return something, but I don't want it to return 0. Not yet. I want the test to fail. Remember, step 1 of test-driven development is, repeat after me, write a failing test. Unless the test fails, you don't know that the plumbing is correct. But once you see it fail, in the way you expect it to fail, then you have confidence in your test. Let's test. Build succeeded. And there it is. Just what we want. It says expected 0, but was -1. Now, so that proves that the plumbing is correct for it to invoke this method, that this is the value here that we're getting back. So, now the fun. Step 2, write the simplest code that passes the test. Are you ready for this? Are you ready? Here we go. Ta-da! Let's run the tests again. And it finished testing, and we are good. Now, you may complain and say, this implementation is really stupid. Yes, it is. That's because it satisfies in the cleanest way all the tests we have so far. So you see, as we continually refactor, we keep the code as clean as possible. In fact, step 3, I forgot, is to refactor the code. There's really nothing to refactor yet because we're just getting started. So let's move on. That's the end of test 1. Now let's test another requirement. We want this value that was generated to be saved back into user defaults. it is very, very tempting for the beginner to come here and add like some other verification in here. Do not. No, resist. Resist the temptation. Ideally, each unit test has a single verification statement, and we want multiple tests. We're just going to copy and paste this to get us started so that we can replace this with something else. Let me express in the test name what I want it to do. Instead of should return 0, it's really should save 0 in user defaults. With all the same setup, only this time, instead of that, I want to say, I need to ask the user defaults if the thing I expected was called on it, on the mock object. So I say verify on the mock user defaults that set object zero was set for the key current reminder ID. Like that. I was like, why am I getting an unused variable? Well, that's because I ripped out the execution portion that was originally in here in the first test. Really, this is now going to look like this. I'm going to say, when I do this, and I don't care about the return value. Does this make sense? Given all the same stuff, when I execute that method, when I invoke that method, verify that setObject for key was called with these values on the mock user defaults. All right, let's test. By the way, instead of always coming back up here and clicking this button, the shortcut, the faster way to operate, and fast is always good in TDD, is Command U. Let me just do that right now. Command U. And I want the test to fail. And indeed it does. That's good. Step 1 is complete. Because it says, I expected this invocation, but I received 0 of them. That's exactly what I want. So now, step 2, the simplest code that passes. Well, first we need to modify this to actually use the user defaults because we need them in here. Right? What I want is to say user defaults set object. Well, this is just going to get ugly to type. Let me first set up an instance variable and say in the initializer set it to what is passed in, and then finally set object for key. Now what do I want? Well, what's the simplest code that will work? Again, this looks really stupid. That's okay. With that, I am now ready to Command U to run my unit tests again. And it finished testing, and this time we passed. You can check the log. There's a green check mark over here to say, just to look back and see where things passed and failed. So this is good. We've done step 2. We're not done. Step 3 is to refactor. This code looks clean. This code looks clean. But we know, because we copied and pasted, that the test code has duplication. Let's get rid of it. Let's bring some stuff up into the IVARs of the test class, and that creates what's called a test fixture. So let's go like this. Let's copy this up to here. It's going to give me some warnings, so I clean that up like that. And here's another one. Copy that in here. Make sure that it's using all that. And let's copy these two lines. I'm not going to copy this one because this is going to vary from test to test. Let's just copy these two lines. Now where do they go? Again, using my handy code snippets. If I type setup, then I get the setup for the test fixture that will be invoked before each test. And I can say like that, and in a corresponding teardown, the mock object I don't really care about, but I want to make sure that the system under test is properly deallocated. That will test its life cycle. So now we can get rid of that. Get rid of that. You know what? Do I really want to keep that down there? I don't know. I don't feel good about leaving this after all, because I haven't, just because I'm anticipating the future, I need to live in the present. So let's get rid of that as well. There. Now look at the tests. You see how this cleans stuff up? But of course we need to make sure that this worked. Refactoring has to rely on unit tests. If you're not using unit tests for refactoring, you're not refactoring, you're doing something else. But this is refactoring. Command U to run the tests. I expect it to pass. And indeed it does. So this is a successful refactoring. We are done with test 2. Now we want to test that if the user defaults does have a value for the key, then we return one greater than that value. And as always, step 1 is to write a failing test. Let's take this test, which checks for 0. I'm going to copy and paste it down here and tweak it. Next reminder ID with no current reminder ID and user defaults. No, let's change that. With current reminder ID and user defaults should return not 0, but 1 greater. Let's pick an arbitrary value of 4. In which case, the setup for that will be to return 3, like that. Command U to run the unit tests, and it fails, and that is good. Step 2, let's write the simplest code to pass this. So we come over here, and from user defaults, we get the object for the key in question. And let's put that in a variable, say if there is such a value, then return, I'll get its integer value, add 1, and turn it back into an NS number. Like that. Let's try that. Command U. And we're good. Step 3, refactor. I don't like the way that setup sets up the mock object here, but with a certain fake value, but then it's overridden for this test. Let's move this back down. I know, I just moved it up. But we want to live in the present, not in the future. Because the present will guide us in ways that we might not expect. So now with this, let's run the unit tests again to see if this refactoring was successful. We're good. Now we have duplicated code. Even this is very similar to this, except for the value. So let's take this value, nil, and extract it. If I were using app code, it would be very easy to do with an extract variable refactoring. Xcode is not as kind. We have to do it by hand. So I'm going to pull this out like that, and I'm pulling it out to set up a refactoring. I'm making the value not generic. You know, what's it? You know what I mean. Programmable. Now I run the unit tests. I expect this to pass. Now I can take this and do a refactor, extract, and I'm going to call this set up user defaults with current reminder ID. Like that. That all is fine. No, I don't want snapshots. So I've extracted this helper method, and it's using it here. And now I can inline this variable, again with app code. That would be done for me, pretty much. Now I should be able to take this, bring it down here, and here accept the value will be 3. Like that. Let's see if that works. That's pretty good. Let me add a few comments in here the way I like them. Like that. And that gets us a step closer. We're almost there, folks. Now for our final test. We want to use these same conditions, but instead of checking the return value, we want to see that it's set back into user defaults with 1 greater. Let's take this test as a starting point. Copy and paste it, except next reminder ID with current reminder and user default should save not 0, but 1 greater. And taking our arbitrary value of 4, and the fake setup for that should be that it returns the value in user defaults should be 3, so that then it sets 4 back into user defaults. Let's take this, Command U, expect it to fail. It does fail, and that is good. And that is step 1, a failing test. Step 2, the simplest code to pass. So what do we want to do? We want to change this, but we're not getting there. This return is getting in the way. Let's say reminder ID equals, and you know what? Before I implement this, I want to do some refactoring over here. And in order to do that, don't ever refactor with a failing test. Always come back to a clean state. And let's see if we can't get this to work with our new variable here. Command U. And look at that, it didn't work. Why not? Because I forgot that if there is no value, then the default, the initial value, should be 0. Let's try that. That's better. So now we've refactored. Again, let me repeat. Don't refactor when you have failing tests. Always refactor from green. Now let's bring this new test back into play. Run it to make sure that it fails still. And that's good. Go like this and use that variable here. And we are good. And it's tempting at this point to say, woohoo, we're done. Because it sure looks like the original code or something close to it from the problem. The test code looks clean. I don't see anything really to refactor in here. Header looks clean. This looks clean. Oh, but wait. I just started watching Uncle Bob's Clean Code video series. I highly recommend this series. You can get it at cleancoders.com. In episode 3, he asks the question, how many lines should a function be, or method? And says, really, the ideal is about 4, which is rather remarkable. 4, huh? Well, let's make this bigger so I can see what's going on here. There's just our implementation by itself. That's more than 4 lines. Why? Is it doing more than one thing? Well, yeah, I guess so. Again, Uncle Bob's rule. How do you know if a function is doing more than one thing? And the answer is, if you can extract something out of it, it's doing more than one thing. Look at this. There's basically 2 halves to this. One is determining the next value, and then having determined that value for the reminder ID, we do some stuff with it. So let's take this and extract it. And the reason I can do this is because I know my test code is covering me. All this stuff is fully under test. I can refactor boldly without fear. Say determine next reminder ID from user defaults. That's pretty good for now. So now it's pulled this out. Let's clean this up a bit, because it's setting this variable, and all it's doing is returning it. So really we can just go back to a straight return here, straight return here, there. That cleans that up. And here, of course, we don't need this split across two lines. That cleans that up. Command U, I expect this to pass. This is refactoring to go from green to green, and we're good. Now, I still don't like this. Look at this. We've got this key repeated here, here. Now it's kind of split across two methods. Let's pull that out into a static. Current reminder ID key. Like that. And run the unit tests again, and we pass again. Now, I'm going to use this constant any place that the key is used here in production code, but I'm not going to use this. I'm not going to share this with the test code through the header file. I want the test code to be ignorant of this, so that, let's say something bad happens and a typo occurs here. Well, this will fail now because the test has its own sort of knowledge of what the key should be. Time for a quick recap. First, avoid Apple's test case template that splits tests into a separate header and implementation. That's simply unnecessary. Instead, use something like mine where it's all contained inside a single file. You'll just be happier for it. I like to use OC Hamcrest for my test assertions and OC Mockito for my mock objects. Remember dependency injection, the two types. There's property injection, but what you want most often, is constructor injection, which we used here. I set up my panels so that the entire left side here is the test code. On the right, I have the production code with the header on the top and the .m underneath. And that way I can see everything I need to. With all the production code visible right now on the right-hand side, notice how much test code there is. Look at the scroll bar. See that? It's about twice as much test code as production code. That's not unusual. Don't be scared of that. Remember the TDD three-step waltz. Step 1, write a single failing test. Step 2, write the simplest code that passes the test even if it looks really stupid. Step 3, refactor, and you refactor everything here is fair game for refactoring. Production code and test code. When refactoring test code, you can pull variables up into IVARs. This is called the test fixture, which is set up and torn down before and after each test. And that's it. Go forth and TDD. Please leave comments. I'd love to hear your experience with this, especially if you have any questions. If you leave comments on the YouTube page, I may not see them. Come on over to qualitycoding.org. I've got a link here for the corresponding blog post for this screencast, and leave your questions there, and I definitely will see them and respond to them. Thanks a lot.